Okay, I want to start with a small question. It's not this button, it's this one. Is it better white screen, non-white mode, or dark mode? Can I get a small raise of hands? Light mode? All right. All right. Okay. And last thing is connecting to my hotspot. All right. Oh, good. So, hi everyone. Nice to be here again, another year. As you can tell by my name, I'm Spanish. But I live in Berlin. I joined Vercel recently to work on open source, on Nuxt, and a lot of all this stuff. You can find me around as POSVA or ESM, which are my initials, not ECMAScript module, .dev on Blue Sky. And today I bring you a topic that is very dear to me, which is both state management and routing. I want to present to you how to do type-safe state URLs. And when you think about state, you might be thinking, well, what do I need another state? I already have so many ways of doing state. We have these ephemeral local reactive state with ref, shallow ref, reactive. We have global state with piñas or uStore, user, view use. So it's global, but lost on refresh as well. And you have composables, which open up all the possibilities you might want. For example, to have, well, in this case, local storage, but it could be IndexedDB or anything else. And you can also have more complex behaviors, like ref histories. So you have a time travel feature, more or less, in your state. But all of them have something in common, apart from being state, is that they are internal, in a way. They are never exposed to your user, right? They're exposed in UI, maybe, but they're not exposed as a state, as a property that the user can change. However, the URL does have that property built in. And the URL as a state is divided in a few pieces. You have the domain, which we forget about it, because we cannot really change it. And then we have the path, or the path name, which it's usually consumed by the router to define the page you're seeing. We have the query, which is a little bit freestyle. You can put anything in it, usually optional stuff, like, well, search, filtering, but really anything. And then we have the hash, which is mostly used for anchors. So in Wikipedia, if you share an article, you can scroll automatically. But you can put anything you want in it. And it can have some really nice use cases, actually. One of the particularities of the hash is that it's not sent to the server also. So it bypasses some limitations of URLs, which are very interesting. Now, what is great about the URLs as state is that you have some superpowers out of the box because it's a URL. The first one, and I think this is the killer one because it's the only one that is not, it cannot be done with any other state, is teleportation. You can take the URL, you give it to someone else, they are teleported to wherever you were. This is something you cannot do any other way. And so classic thing is I search for a product, I share that with another friend. Hey, what do you think about these sneakers? Oh, they are ugly as hell. Take something else. But you can also have things very advanced, like the playground on the Vue on the Vue core repository that we use for reproductions. It's on the right, has the whole code that you see in the hash, and we can bypass some limitations by compressing and doing other stuff. But all of these, well, you cannot do it on any other kind of state. It's only on the URL. Then we have the built-in time travel. And I say built-in because you can have time travel with a ref. But basically, the browser has this back and forward button, or swiping left, swiping right. Users are used to this. And if you design your application around the state, around the fact that the URL is state, then you have built-in time travel. So this is really nice. And users expect this to work most of the time also. And last but not least, we all often forget about this, but we have a communication channel, thanks to the URL, between the server and the client. We can pass information in the URL. The server can change that information as well. So it can give us information to the client. Very common use cases, authentication. Your user visits a page. They are not authenticated. They get a redirect with a new page and a redirection in the query, because you can put anything in the query. And then maybe after the login, you get the actual page you're going to with the token, which is state you can preserve in the page. So very classic auth mechanism. Now, there is a big catch about the URL, is that it's just a string. So just a string means that, well, if you want to add a number to a string that is a number, you're going to have some trouble. If you want to do false, you have more trouble. And if you do other crazy stuff with numbers, it's even worse. So this is pretty much the state of the things today, I would say, with the router, is that if you get the params from the route, you get all the possibilities. And in fact, depending on what you use, if you have other roles, you have type safety for the params themselves. So you know that your params object have specific keys that you can access. Otherwise, any key is possible, and it will give you a string and an array of strings. But in fact, well, some of them are going to be undefined. The problem is that if we need a number, if we need to validate anything, we need to handle the parsing ourselves. And we need to handle the parsing, but also the error handling, and what do we do? And if we have different kind of errors, what do we do? With query params, it's even worse, because we have more possible values in it. So you need to handle more use cases, like here, rejecting also the arrays, or maybe using the first value. It's up to you. There are so many possibilities. So it's even worse. And if you use this in a page, well, it means that you have a lot of validation noise in your page, which is just when you read your component, it's going to be noise. And in the age of agent, the noise is what we call context overflow or overload, which is also valid. So all of this is just validation, and this is the actual code that we care. But then we also have the error handling that might be useful here or not, depends on the errors we have. Do we really need to show to the user that they provided an invalid number? Maybe not. And so my proposal is, what if it just worked, right? What if the params that we get from the route was actually typed as an object with these properties, and these properties could have different values, not just strings also. Anything else on the param will be undefined, and it will be type checked. And if you try to access it, you get an error. So this is what I want to do, or this is what I would do with view router resolvers. Not just a name, not fancy or anything, but at least it stays close to what it does. It's about resolving URLs. And I'm going to show you what you need to do in order to have it. Now, first, you need to adapt your routes. Normally, you have some object that defines a route with a name, maybe some component with a lazy import, and a path that is then parsed by the router. So we're going to change all of this into an object a little bit more complex, where the path becomes a specific thing that we call matcher, and we do the same for the query. And I want you to give a few seconds to look at this code, okay? And I really hope that in your head you're going like this. Like, what the hell did I just watch? This is real code, okay? But it's not code you're going to write. And this is key also. Because it allows us to have something that compresses well, is performant, using classes with some very specific options. But yeah, let's face it, I'm not even myself, I would write like this any code. So what do? Well, we generate this code, not with AI, but with something deterministic, with a compiler. And the first thing we need to do is to have a file-based routing. Now, I want to know who uses file-based routing here? OK, I was a half, more or less half. So for those who do not use file-based routing, at least with view router, OK, who has used the new view router file-based routing? So I guess everybody's using Nuxt, which is using this under the hood. But so this is the merge of the unplugging view router, if you've heard about it, which is also used by Nuxt. Now it's removed, it's replaced by just view router. It enables file-based routing, and it has a very extensible configuration. So you can really have domain-driven architecture if you want. You don't have to have these page folders. You could have an extension on the component. You can filter out components so they don't become pages. It's very flexible. Really, if you haven't tried it out, give it a try. It makes your routing so much easier. And also gives you type safety, which is going to be really nice. So the first thing you do is you add this plugin, if you're not, and then you enable the experimental param parsers, which is going to be the default on the next version of the router. But for the moment, it's just experimental. And then you need to use the experimental router. Now, if you are using the file-based routing, the change is going to be very simple, because you already have these two lines in your code where you import the array of routes that is generated. And now, instead of passing the routes, we are passing a resolver, which I'm going to show you later. It's interesting, but it's generated code as well. And we are going to move some of the logic that was runtime, like parsing, route sorting, to the build time. So not only is faster than in execution, but it's also lighter. So it's really nice. Then you can define parameters. So you have your route, in this case, a page, which is pages/product ID, and it's between brackets. You can do equal int, and it becomes an integer. You can also use define page. So you have these macro, similar to define page meta if you use Nuxt. It has different parameters inside. But you can define these params object where you can customize the behavior of the params. And you can add param parser, default values, and stuff like that. And so for the path, you have these object where you can define, and everything is type safe. You have the ID that you can define there, and then give a parser. And then query, you have more options because they are more flexible. And we're going to show that in a demo very quick. Now, of course, there are only, for the moment, two native param parsers, which are int and bool. I might add or remove them later. The default is just string, as you can imagine, which is worth adding, by the way. But you probably need custom param parsers. So how do they work? You have a new folder that you can create, params, on your SRC or your application folder, where you create any TS file that exports a param, or a parser, sorry. And then you can add the equal name in the file name, and it works. So for example, here what we have is we use define param parser. We pass the type generic just to simplify our lives, saying, OK, I'm expecting to transform whatever param I get, which is going to be a string, into a date. And then you have the getter and the setter, which are going to, well, do the two-way, the bidirectional parsing of this information. So in the getter, you can also throw errors. Miss throws an error. And this is going to decline the param in a way, so that the router is going to decide that this route cannot match because the URL wasn't validated. So it's going to keep trying to match other routes. Okay? That's how the resolver works. And this is what we call a matcher behind the scenes. But in the end, it's just about when you do router push or router resolve, the router is going to try to resolve the route based on what you give. And if the param is not valid, it's going to skip it and try another one until it finds nothing and it goes 404. What is nice is that the setter is also simpler sometimes. So here is just taking the string, the date string, and taking the beginning without the time zone with the time, because date time otherwise. And the validation will happen in the getter anyway, because in order to normalize params, we need to run both the setter and the getter. So you can write the normalization, the parsing and the validation only in the getter, which is also nice. All right, and now I want to do some demo to show you these things because it's way funnier to see the demo by yourself. Is it big enough? Cool. So I have the server running on the background here. This is the vconfig to show you that I added this view router. There is a little bit of lag between the screens, so you're going to see me do stupid things sometimes. And this is my demo, so a little bit of nostalgia for some people, for millennials mostly, where I have a search where I can search. I can search things like here Photoshop. I can also search for a very old friend Flash, and I can have some filters. It's hard with lag. And the URL updates, I can check the product, and I have that in the URL. And I have other things like, for example, if I go to a product that doesn't exist, well, I can display an error, but you'll see that something that doesn't look like an ID also gives the same error because it's not handled. But we could handle this a little bit better. So let's do that. I go back to the application. I'm going to show you the product ID, which is this one. And we're going to see that we have a few validation mechanisms going on. So we have this product ID here happening with a cast, and we wrap it in a computer to just simplify things, and then it's used in another computer to get the product, and it's going to give you no otherwise, and that's going to be used for the not used message error in the end. So if I want to use the ID, the int, param parser, I can go here, define page, and then go with params, path, and then ID, and then I have the int here. Now I save, and what happens is that this param has become a string. Do I have the server running? I'm going to remove. Wait. Oh, restart. A string. OK, let me check. Do I have the server running? This works normally, so that would be weird if it doesn't work now. And it's because I have a typo. So product int, there we go. OK. So now this has become a number. All right. There you go, a number. So we can remove all of the validation here, and no errors will appear. We can remove the number here. The validation of being an actual number, we can also remove it. We're going to keep the null, I think. No, actually, we don't need to keep the null. Oops. So now the page is going to just work. The lag is really hard. Sorry. There you go. And no errors at all. We have the same code everywhere else, but the page is going to give me a 404. So it doesn't match anymore. It goes into the 404 page because this is not an integer, so it doesn't work. The other one is still the same. All right. We can go a little bit more complex. So we can have dates, for example. Now, this one is a little bit more interesting because, let me show you. What is the page? Events. Events and when. So you can see this, that I have the when variable here, and I'm parsing that into a date. And then I have a lot of validation happening because it's going to be a date. So here I have the isValid, and I'm going to see the isValid in a few places, like here, 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 here. So we have a lot of validation noise spread across the page. Now we're going to remove that. So we're going to go here and do define page, and then params, path. And this is going to be when, and it's going to be a date. So before saving, I can show you that this is a string. If I save, and I check it again, let me check. Now we go. It's a date. Okay. So now we can remove a lot of things. We can remove new date, and we can completely remove isValid. So this is my favorite thing in programming, is deleting code. Yeah, don't need that. I don't need the format thing. I can do this. And I can remove the error state here. And I can keep going. It's always valid. Obviously, I would do this with an LM, but I want to show you the changes that I have to handle here. So here as well, no error, no error. And then same. What else? The invalidate, it's not going to happen. And that's it. So we have one error left, which I'm going to talk about a little bit at the end. But the application now is going to work the same way. So we have today. It's a date. It's just that the type of the value that we have is a date. But if we go to something not valid, so if I go to this, I will get a 404. Now the Go is broken because I didn't fix it here. But what I can show you is directly from the URL. So this is going to give me a 404 now because this is not a date, so it doesn't match the constraint we are specifying for the param. And if we want to fix the last error here, we have this push that is not going to work. And the reason is very simple, is that when now should be a date. But here we're giving a string. So the router is expecting to give the actual type of the param that we're manipulating, because the idea is that the fact that the param is a string behind the scenes shouldn't affect your code. Your code should only handle a date. That's the actual type you expect. And you don't want to handle the validation or the error parsing or anything. Here, I'm actually going to change the route into something very simple. It's going to be this. So when is a string because it comes from the input that you saw. So I can type any string. It is not parsing to a date. You could parse and validate a date if you wanted to, but why? If the param is already doing that. The param parsing is already doing the parsing for yourself. So here I'm using a relative URL, which allows me to just change the last segment of the URL. And now if I go back, I can write anything here, and I will be able to see the error. Does anybody have any questions so far? Since I know that there are question time later. All right. In that case, I'm going to go into another smaller demo, the search. So queries are the same in a way. We want to put state in the query that doesn't make sense on the path, and we want to validate that data. But the thing is that it grows very quickly into a lot of validation noise. Here, I have all these parameters. So it's the page I showed you before, the Photoshop. So you have the minimum year, maximum year, the price, et cetera, and also a search filter. And they're connected to the URL. If I want to change things here, I'll do the same thing. I can do define page, and then do params. And here I'm going to only have queries and have Q. And Q is going to have a default value, because I don't want to have to handle undefined. The idea is that most of the time the queries are optional, and they shouldn't block the user from visiting the page, right? So you want them to be a little bit more, what's the word? Easier to use, more, I forgot the word. You're going to see that in a moment. Usable is not the word I was searching for, but yes, also. So here, we're using the query. The query is still, let me go there, is still any possible value. So it's still an array, maybe a string, maybe null, maybe undefined. But now, the Q has become part of the params, which if I don't make a typo, I will be able to use. And so, why is it? Do I have a typo? Find page param query, Q, route. Let's see, I think I have some issue with the language server, but the type is here. So if you look at the params object, it's also interesting. There we go. No. Can you please? Thanks. So the params object is really just that object specifically. So it's performant also for TypeScript, despite what you might think with my setup going on here. And I can get the Q. I don't need to handle all the defaults. I had a syntax error here. Yes. And here, Q, this is fine. This is a search, so I want to display all results if I don't have anything. I don't want to just put 0 things. And that's it. So that's the query. And I can do the same for the page. So that page will be a parser. This one needs int, and then the default is going to be 1. And of course, I can do that for every single one, but because I'm a little bit lazy, I'm just going to go with the agent, in this case, codex. I'm going to tell, hey, look at the parsage, the page search of view. I already migrated one of the query params to over the params, apply the same to all the ones. And it's going to go, and it should be able to pick it up very easily, and in a few seconds, give me back a fixed page. Or so, but of course, I need to connect. It's connected, it's connected. So normally it's a bit faster because this is the Spark model. But it can make mistakes anyway, so. Yeah, this is very slow for the model. So it's going to repeat the same migration process. It's going to explain what it changed, and we're going to see if it makes some mistakes or not in the end. Usually it does a few mistakes. Wow. All right. Almost done. So what do we have here? I'm putting it on pause. It's removing every single computed. I'm keeping the computed just to simplify the example, but of course you could also get rid of the computed altogether. And I'm putting that there. Just, well, now we have the right values. We completely remove all the validation logic. And then it's going to change a few things. Yeah. So in the params, as you can see, it passes all the params and updates, but it removed the query completely. The query is not type safe, right? You can put anything in the query, even params that are not meant to be there. That's part of what you expect from the query. But you want these params to be typed. So you can put only the specific things, and it should be type safe as well. So I go here, and I go to again the language server. We can see that we have everything type safe. There is no errors in this file. It's green. So how does it work behind the scenes? I'm going to give you a very quick glimpse of what it does. So we generate on the fly this module, which I don't expect you to read, but it contains all the unreadable code that I showed you before. Well, a few comments. And so this is the parsing. It's at build time, and the sorting is also at build time. It's here. And that's the magic behind it. So this is how we achieve a better or a more optimized router. I don't want the cursor. There we go. Now I want to add a few final notes. Is that, as I was saying, not all parameters should be equal. Path parameters should be very strict. If you don't provide what you expect, well, it should be a 404. It shouldn't match the route. However, query parameters should be resilient, which is the word I was searching for before. So if the parse fails, they're going to fall back to the default value or just give undefined by default. You can make them strict if you want, but it's an opt-in mechanism. Whereas with params in the path, you cannot do that, unless you make it optional, of course. But it's just strict. It's supposed to be strict. And the idea is that you should always render the page with valid data. That's the important part. That's what I want to achieve. It just simplifies how you write your page. But don't put everything in the URL, please. There are a few limitations. Don't create URLs that are above 2,000 characters. Now, this is just to maximize cross-browser support. You can imagine where this comes from. Can anybody guess? Internet Explorer, of course. And nowadays, Edge. Okay, they kept that. I don't know why. But it's just how it is. The thing is, it doesn't contain the hash, so that's why we can use the hash for some local state that is not passed over the network, but can be shared. So worth having in mind. So yeah, use the URL for navigation state, not just storage. Things you want to give to another user when you copy, when you share the URL. Also, another consideration, if you care about SEO, it's important that you have one URL, one page. All these ref banner, UTM source, make sure that you add a canonical URL that discards these query parameters. Because otherwise you have 3 competing pages for the ranking on SEO, and it's going to impact poorly your SEO. For canonical URLs, it's very simple. Strip anything that is cosmetical, but keep anything that changes what is rendered on the page. All right? If you have a different page, different feature, you should add a different canonical URL, because it's a different page, technically. However, the ones that are cosmetic, no, they should all have this canonical product URL. So the real question is, when can I use this? When do I have access to vRouter 6? vRouter 6 is around the corner. I'm almost done with some of these features. But you can already start using the experimental router if you want. I wouldn't recommend it for production applications, except for internal ones. But yeah, if you use them, give feedback, please. The repository is really nice. It also has nice benefits like performance, and also an improvement in size, almost 30% reduction. And this is including the router link and router view components inside of the bundle, because the current version of vRouter doesn't let you not use the router link or router view, but the new version will not include them by default, so you can put anything you want. And this is to support Vapor in the future, so we can choose which version of router link and router view we use. But these are good numbers. The 6 kilobytes for a router with components, there is no other router that small that has as many features. So my advice is get prepared to the changes. In the past, we were doing just row strings, no safety route params. We have even no safety on the param name itself. Nowadays, you can already use type routes with file-based routing, and you can already get a proper type safety on the keys of the params, but also if they are strings or array of strings, you also get that safety. You can start using bidirectional validators. So if you want to use Zod, Valibot, make sure that you have these bidirectional validation, unless it's just string of something that transforms the value into the actual value. Because otherwise, if you want to have a complex object like a class or a date, well, you need to handle how you transform that back into a string. Most data or simple data are just going to be string of something and it works, so that's fine. But codec is, for example, one of the examples that one of the APIs that allows us to already author bidirectional validators, so it's nice. In the future, you will be able to just use that for clean routing, and you could even use the bidirectional validators that are exported. There is already support for just standard schema validation on the params, because as long as the setter is just string of whatever you give it, which in a lot of cases is enough, because it gives you also a parsing mechanism on the value itself, like maximum number, minimum number, this kind of stuff. And so yeah, give it a try. The demo I will post later on Twitter, and the slides as well. And come see me if you have questions about file-based routing and stuff. And thank you for your time.